Hey, folks, welcome. Welcome to the 94th episode of Quarkus Insights. We have an all Greek cast for you today. So, besides myself and Dimitris, who will be presenting, we also have the wonderful folks from Scientific Games to talk to us about their journey with Quarkus. Before we get into that, Dimitris, do we have any news to share with everybody?
Yeah, well, Quarkus 2.10 went out last week, and it has some preview on Loom features. So check it out. There's a video also doing some explanations. So yeah, I think that's one of the nice things. Do you remember anything other, George?
Yeah, I'm looking for the links because our J Nation talks now have been shared on YouTube. Anyway, I'll post those in the chat once I find them. So yeah, let's get into who's with us today. So we have we have Panos and Christos with us today. So you guys want to introduce yourselves?
Yeah, I'll go first. Hi, Dimitri and George. Thank you for having us today and giving this opportunity to talk about Quarkus. My name is Panos Theocharis. I'm a software engineering manager at Scientific Games. I'm with the company for almost a year now. During my experience, I have worked a lot with the technologies of the JVM ecosystem. I first heard about Quarkus in one of the talks of George. I would say it should be around 3 or 4 years ago, where George was advocating in several meetups for Quarkus. And since then, I guess, I was waiting for the opportunity to use it in a professional environment. So that's for me. Chris, do you want to go next?
Hello, my name is Christos Peristeris. Nice to meet you all. I'm a senior software engineer acting as lead scientific games currently, colleague with Panos, same team. Mainly backend developer, experience with the various known, let's say, enterprise frameworks like Jakarta, the Spring framework, recently Quarkus, and very, very grateful to come in contact with this framework and see the evolution that it brings with. My domain, let's say, of developing applications was with sports betting and lottery domain. Previously, companies Intralot, Camelot, Agile Actors, and currently with Panos in Scientific Games, Europe and Athens.
Chris, you have extensive knowledge of Spring. Is that correct?
Although I don't, let's say, boast about it, I do have many years experience with that framework. Previous, let's say, Java applications we were developing for both for Intralot and later on for Camelot were based on Spring. Initially, it was like Spring Core, then moving on into Spring Boot framework as the years went by, and recently I came into contact with Quarkus. So yes, I do have some previous experience with Spring.
Extended one, I would say. Maybe Chris is not so, willing to tell it so, but I would say that he has extended experience. He also is an instructor giving lessons around the JVM ecosystem. So,
Yeah.
Nice.
Panos, there is some background noise. I think it comes from you. So
I know this is the funny thing with, let's say, the Murphy's Law. The neighbor just decided to use his drill like on 4 o'clock in the evening.
no,
And it's coming from me. Actually, I can shout at him for a moment if you allow me to.
let me check a
I
bit.
think it's from
No,
Panos.
it's from me, Panos. It's a drill.
It's not a drill, it's voices. So, okay, maybe you could say a few things about Scientific Games. I know many people know it, but it wouldn't hurt if you say a few things as well.
Yeah, I can take this one. So we work for Scientific Games Lottery. Scientific Games is the largest lottery technology provider in Europe. It provides games, technology, and services to more than 130 lotteries in 50 countries around the globe. The headquarters are in Vienna, Austria. There are many teams distributed in several countries across Europe. We collaborate in a fully remote work environment, and we work with all these teams together to create software products for lotteries. Actually, we have a Greek branch which was launched just in the last September. Our team, our Greek team, let's say, is located in Athens, Greece, and we contribute to the development of gaming and business platform, which is the goal of the company. We collaborate, as I said, with other teams across Europe, and we build a new product. This is how we met, let's say, with Quarkus, but we'll talk again. We will talk about it in a minute.
So yours is a new team, right? So you do
Yeah.
like newer stuff, or what exactly does your team like handle?
Correct. We started as a new team, as a fresh team, and the task was mainly to create new application services based on Java. And since we have the chance, to create application services from scratch, that was a great opportunity for us to explore what technology is out there currently, what new framework can we use, and always having in mind what is the current situation with the company and what it might fit the needs of the whole organization, and not just of our team in Athens. We work in a product which is built in a microservice architecture. So this means that the teams have the ability and the freedom, let's say, to use some tools, but of course we want to have some, let's say, a common approach that we design stuff, and not, every team uses something different, but rather having a, let's say, a set of technologies that we use in order to be able to share with other teams, ideally. And if something new arrives, which is it's a good option for a specific use case, then we can share it with other teams, as it happened also for Quarkus as well. And so that's the whole, let's say, story of it. We started as a new team, and we tried, to see what we can introduce to our company at a technical level.
Mm-hmm. Nice. So how did you decide to start with Quarkus in the first place?
So choosing the Java framework, let's say, is one of the first choices, one of the first decisions that someone has to make.
Hold on there. Just before you get into the Java framework, how come you chose Java in the first place?
Java was, let's say, one of the hard requirements. Let's say every team in Scientific Games is using Java JDK 11 currently for this new product that is currently being under development. So Java, was let's say one of the technologies that we should also use in our team as well. So
gotcha.
We're talking about Java frameworks here, and I would say that Quarkus was, let's say, our initial. Our first feeling was that Quarkus was the right decision. Let's say it seemed like a great fit for Scientific Games and for the products that we're building. So we tried, let's say, to validate it and find the reasons and the correct justifications behind it to say that yeah, this framework fits very nicely to our needs. So what we did actually, long story short, is that at the end of the day, we created an architectural decision record document, which was drafted by our team, together with all the context details. What is the decision, the proposal actually, what is the criteria that we based upon, and this decision was then approved by the VP of Engineering of the company, and we started working with Quarkus since then. It is when you work, for such a big team, as I said before, having a common, let's say, tooling, a common stack of technologies is essential, because what we are building now, we don't know if tomorrow, let's say, the software that we build might be used or may be maintained by another team inside the organization. So
I was curious, were you the first team to use Quarkus?
Yeah, we were the first team that we used Quarkus, and I think now it's the time, to say about more details about the context, about the background, what was the story when we landed in the company. So the company was using Java Enterprise, Jakarta Enterprise technologies, Oracle-oriented as well. They were using OpenShift platform for deploying and make releases in production. They had, let's say, direction of not using a very opinionated framework, but rather using Java enterprise libraries. That
So
was
they
the
would
direction that,
stitch them together on their own, like a custom.
they were, all these services are being deployed to a Payara server. Payara server is being used as a runtime, which the company uses to deploy containerized services, Dockerized services in there. And the code, let's say, would follow a microprofile specification using the Jakarta libraries that we know, JaxRS, Eclipse Link, and other libraries at this space. And for us, one of the first things that we saw is that, I think it's very, let's say, it's a low-hanging fruit here to check whether how we can improve, let's say, the development experience, as we say it very broadly, by introducing a framework. But on the other hand, we would like to respect the fact that the company, would like to maintain, to preserve a coding style which is more Java EE, let's say, related. So Quarkus at this point was fit very nicely at this environment, because at first someone can use the Quarkus as a runtime, import the Quarkus libraries, and still continue to write Java Enterprise with the same libraries that was using before, without making a lot of, let's say, changes, or a lot of having a, let's say, a steep learning curve at least for the beginning. I mean, okay, as the time goes by, maybe more framework stuff someone might use. So this is one of the things that we would like to preserve, this coding style stuff.
Yeah, just to add here that
yeah.
I think people appreciate this, that Quarkus supports lots of either standard or de facto APIs, whether they come from Jakarta IE or the framework themselves. So the learning curve for that part is relatively minimal. But then packages all together in, let's say, the Quarkus way, which provides this extra layer of usability, standard Java, native Java, configuration and all the good stuff, developer service, all the good stuff that comes with it. So I think you are right in saying that Quarkus is not opinionated, but it is. It's not when it comes to the APIs, but it is on how you combine the stuff together for
Yes,
the most common
absolutely.
case. Yeah.
Actually, the development model that Quarkus adopted is very, very close to like writing an enterprise, a Jakarta application. So whatever you have there still can remain in terms of, let's say, all the annotation being used, for example, observable events, the CDI, the injection pattern, and all this stuff. So it looked like Quarkus respected all the good parts of other frameworks as well, like the Spring or Spring Boot, especially Spring Boot, carrying all the sensible defaults that Spring Boot actually would give, like, for example, the contained runtime environment, which would make things also really stand alone in terms of being giving the ability to developers to test something on their own machine without having, let's say, to have a container at some point, at some place. So actually, Quarkus respected a lot of this. It conveyed to also a lot of enterprise specifications like the micro profile, again, which made things really transferable, let's say, from being really a traditional application to a Quarkus one. So this also made things a little bit more straightforward in terms of how a migration could be for already existing applications as well.
Yeah, and I would like to add here that, like, just to emphasize. Oh, there's some background noise somewhere. Anyway,
The drill.
yeah. I would just like to say that the fact that, like, Red Hat has a lot of people working in, like, middleware Java, right? This allowed Quarkus to bring all this diverse, like, experience, because you have, like you said, you have a lot of, like, Spring influence, and then you have a lot of Jakarta influence, but from people from both sides of, let's say, the aisle, Quarkus just feels like really close to what they already know, and then they can use it really quickly. So yeah, I would say that, like, being able to bring so many different people together is a testament to Dimitri's level uh, of Quarkus, more than, like, the us coders level.
Really, it shows our
Correct.
heritage, because if you see, who makes, like, the beginnings of Quarkus, there were people coming from the application server space, Hibernate space, performance space, JDK space, security. It's, and all of that bind together with big emphasis on standards, because we're very big proponents of standards where it makes sense. So yeah, sure, totally agree there.
And in terms of the opinionation of the framework, well, it is an opinionated framework in terms of the libraries and the tools that it comes with. But in terms of the development style, it really went besides and aside actually the Jakarta development style. So it was a really straightforward process to, like, be able to use Quarkus, having Quarkus at least for the runtime, and write a Java application, Java enterprise application, and then see how you can actually utilize the Quarkus extensions in order to get all the goodies that it offers.
Excellent.
Should we move on a bit to, like, some more like which APIs you're using and stuff like that?
We also say a bit more things about the decision? I mean, before one
Sure.
factor was the coding style and development experience, and another important factor that we based on in order to take the decision was the performance, right? Right. In our industry, performance is very important, especially the maximum throughput. We have customers that desire, that they want several thousands requests per second. And what I could say is that the company, of course, was caring for that by using, let's say, lightweight Java microservices deployed in Payara, and Payara actually also, I think, delivers a good throughput in production. But there was a room for improvement there, and of course there was also a room for improvement for decreasing the memory consumption and also improving the time to first request. So with Quarkus, what we did actually is that we didn't sacrifice, let's say, the development experience in the benefit of having a good performance. And not only that, we went, I think, one step forward and improved the performance side as well. We are still we haven't deployed anything in production yet, and we cannot, let's say, validate in the real world yet. We are still building this service right now, but we have done, let's say, some basic testing, load testing, and we have, some very good feedback, especially that the time to first request. It's obvious, and you see that the application is, starting very, very quickly and can deliver requests sooner than Payara, let's say, server or other frameworks. And so
Panos,
that, yeah.
This is without using a native image, note that. This is
Correct.
only using the
Correct.
OpenJDK.
Correct. The JVM mode, yeah, correct. Yes. We are using the JVM mode here. And so performance as well, so performance is improved as well. Now, other let's say topics of this decision was the fact that, as we said before, the company was already using OpenShift. We have a subscription there, so we probably have a support for Quarkus at production environments as well. As we said before, we haven't deployed to production, but it's nice to know that there is such an option. Also, Quarkus is a open source, it's actively maintained, it has releases very frequently, and the adoption is growing and the community is growing rapidly. So for us, it seems like, a safe decision to go down that road and have the confidence, to share this knowledge to other teams inside the Scientific Games company.
Mm-hmm.
If I may, right here. Oh, sorry. Go ahead.
Go ahead. No.
I just wanted to ask, of all the things you described, what do you feel were the most important points that you conveyed to the other teams and to management, upper management, that they said, okay, let's go ahead with Quarkus for all our stuff?
Well, the upper management, if you say so, was very intrigued by the low memory footprint. So that was and the quick start, the time to first request as well. But the low memory footprint was, let's say, one of the discussions we had recently, and actually this is the reason we are now investigating the native app mode as well. This is still under, let's say, in a proof of concept stage right now. But I give some chances that we might try that as well. I don't know if we extend the usage, very, let's say, very quickly to a lot of services, but at least, let's say, some of the services might be using the native Quarkus in the near future. But yeah, to answer your question, the low memory footprint was the one characteristic of Quarkus that was mentioned by the upper management.
Excellent. And you talked about support. That's, for those that don't know, of course, Quarkus is a community project and has excellent community support, but we also offer commercial support through OpenShift. So if you have an OpenShift subscription or a Red Hat Enterprise Linux subscription or a runtimes middleware subscription, with all of those you get also.
Yes, you do well mentioning that, because we do, actually the company uses OpenShift as, let's say, the Kubernetes interface provider. So OpenShift is actually the product that brings us Kubernetes under the hood. And since it is a Red Hat product, so these two actually stay under the same, let's say, house, and it actually made things a little bit more easier to communicate as well.
Yeah.
So
You don't have
despite
to pay extra for it. It's just bundled. Yeah, cool.
But I also want to answer what is, the feedback from not from the upper management, but from the development for the developers as well, because what they extremely like, obviously, it's the very fast iterations that someone can experience when developing with Quarkus, and because in our teams we heavily, rely on unit tests, integration tests, etc. We would like, to have these iterations extremely fast in our local development environment, and having stuff like live coding, without rebuilding the application again and again. We can iterate very quickly and see whether our tests are working, our code is working as expected. So our teams are small in numbers. We have currently 3 teams, or from 5 to 6 people. I'm mentioning the structure here in Greece, but this is a similar structure as well in other teams across Europe. And we heavily rely in tests, as I said. Testing is part of the development process. So we don't want to push. Let's say we don't want to wait for pushing stuff in the upstream repository and wait for the CI server, to get the feedback. We would like to get the feedback as soon as possible. So all this testing is also running to our local environments as well. So the development experience actually matters to the developers. And I think it's a productivity booster, which the upper management also likes as well.
Maybe we should get into more details, like extensions you're using, stuff like that.
Yeah. Chris, do you want to take that one?
Actually, we do have applications that span. They are mainly, of course, integration applications. So we do have an application and a platform that is microservices architecture based on, meaning that we do communicate with various clients like front-end or terminal machines. So we do expose APIs, meaning that we need to make use of the REST extensions of the Quarkus offers, like Quarkus REST Easy and Quarkus REST Easy Reactive. There's an asterisk here because actually we do make use of Quarkus REST Easy Reactive libraries, but we do have services that actually do not adopt the reactive programming model, meaning that under the hood, the worker thread kicks in. And we actually do follow, let's say, an agile development model, meaning that we do need to have definitions of done, including automated tests in with JUnit and Mockito. So we do have coverage also being monitored from the relevant tool. So we are also using Quarkus, JUnit 5, JUnit 5 Mockito, and Jacob as well. We do have persistence layer referenced from our applications, depending on the service itself. So we do have microservices that actually facilitate wager requests. We do have microservices facilitating wallet balance mutation requests. We do have player-related requests. Some of the microservices that we have developed are integration. That means they only, let's say, act as gateway. Some others do have the need to refer to a persistence layer. We do use Oracle as a persistence provider. And these actually make use, and this is one of the favorites features, because it actually brings what Spring Data JPA offered in the relevant enterprise framework. So we're making use of Quarkus Hibernate ORM, Quarkus Flyway in order to have, let's say, track of the changes, the DDL and DML changes that an application might need to impose. And this also makes the development experience really, really fluent, because you do not need to refer to a database that exists somewhere and might be also impacted from other users or systems as well. So you do, using Quarkus Flyaway, and also the images that are being used and spawn from the application itself, you can also have built-in, let's say, images that are in the state of the latest image of the application. So you do have consistency between the application and the persistence layer. Quarkus JDBC Oracle, of course, since our persistence provider is the Oracle, and Quarkus Hibernate Panas, as I explained, the DSL feature of this, especially for the simple queries, makes us depend less on the SQL, as we did also with Spring Data. We do want to have documentation in place, Swagger, that will also get deployed as OpenAPI, let's say, endpoints in a relevant company portal. So we're making use of the Quarkus Monterey OpenAPI. And one of the usages is that we'll also expose some liveness and healthiness, let's say, endpoints that are being, let's say, monitored from the underlying Kubernetes container using Quarkus Murai Health. And that's just to name a few of the framework of the extensions that we're making use of Quarkus. I'm not sure whether you have any questions up to this point before we proceed to something more specific, like a use case of our usage.
Quick one, were there some extension you were missing, or everything was there for you?
We do have some points later on. We would like to use Quarkus Hazelcast, let's say, extension. Right now, we are using Hazelcast client, native client, but really, we didn't have, let's say, any feeling of, we didn't lack any major feature that we would like to be provided from Quarkus extension itself. But we can also discuss this later on and points to come.
I have another question. Do you use dev services and continuous testing?
Dev services like?
Do you use dev services and or continuous testing?
Okay. Actually, we're not making use in a great extent of the continuous testing itself. So the button, the art button, I believe, the Quarkus dev mode itself. We do have some issues of our own there that we need to improve in order to make use of this feature specifically. But we do know that there is this continuous testing feature itself that always is in place and can be utilized further.
How about dev services, like to start the database in a container automatically, or do developers do that on their own?
Actually, we do have some Docker images for that. We do that independently and out of the Quarkus, let's say, context. But if this is something that we also could use Quarkus for, to having an image being spawned from Quarkus itself. But yes, we are trying to be as independent as possible from, let's say, environment databases themselves. So we try to spawn the image itself at the startup, the application startup, and of course, making use of Quarkus Flyway to make sure that the database, the spawned database state is at the state of the application itself. And this is maintained through the Quarkus Flyway extension itself.
We have some stuff that we are missing, and I think we will touch them later as asks from the community. It has to do with caching. We know from Spring Data that there is a very handy cache annotations. There are also in Quarkus as well, but we believe they work only for in-memory caching, and we would like to have them configured with an external caching server like Redis or Hazelcast. That's something that we have missed, and we would like to see in the future, and integrate it with our applications. I think that's the main one, and some other regarding Hibernate goodies, for example, nested transactions and stuff like that. But I think the most important one is this one, the caching, the external, let's say, caching server. Other than that, we have used a lot of extensions, but there are still many to use. This is something that it's on us. It's on the next, let's say, it's on our roadmap to use Quarkus Vertex, use more reactive programming style coming from Quarkus, stuff like that.
Cool. Let's move on a bit.
Yeah.
Should you want
Would
to?
you like to give you some?
Yeah, go ahead.
Would you like to give you some small, let's say, application example, use case example?
Yeah, I know you're big fans of Vertex, so you want to talk a bit how you combine Quarkus and Vertex.
Yeah, okay. So it all, let's say, it all coincided by having a look at the architecture needs of the platform itself. So the platform boasted three main types of microservices units, three unit types. The first was, let's say, the cache ones, meaning that you would, let's say, need to have some configuration data being cached. By the way, and to note, we're using Hazelcast also as a caching layer. So we do have some mechanism that refers to Hazelcast and keeps the data in memory in various microservice units. That these are the so-called cache units in our architecture. We do have the business integration units that perform things like orchestration, keeping distributed transactions, tracing, and other business logic. So these have the logic, and we do have right in front and the API level, we do have the so-called API ones, the API gateway units, which actually do not boast some complex logic, or they do not feature anything like business logic or other integration logic. So, and they just there so that they can perform some standard checks. Apart from that, we wanted them to be some lightweight, of course, like the other ones, and perform, as I said before, some standard checks like authentication, authorization of the incoming request, some request validation depending on the request itself. And we would this to be as reusable as possible. So we would like to avoid having, let's say, source being the same and having the URLs being changed only. So if I hear to an API, if I hear to a request coming for a wager service, to identify it and forward it to another, let's say, core service that lays in the behind of the platform. We would like to have a, let's say, a very, very bare mechanism and really lightweight mechanism that would be as little source dependent as possible. So this is where Vertex actually kicked in, and we actually made use, so this is like a very brief diagram of what I try to describe here. All the infrastructure of the platform lays into OpenShift Kubernetes containers. The requests come from outside. Some front-end services maybe might lay here. So the ingress checks on the incoming requests, and depending, let's say, on the request itself and the exposed services, they do redirect to one of our units. So these are the so-called gateway units you see here. So we do have a lot of, let's say, dummy gateway units that do, though, feature some standard checks. And these standard checks actually are libraries which are being injected as Maven dependencies into the Quarkus applications, the Quarkus gateway units. So this black box here, imagine that might be like 1, 2, 3 pods contained into the same namespace as the other gateway units. So this might facilitate wage request, this might facilitate wallet request, this might facilitate player details requests. And apart from doing these simple, let's say, validation and standard validation and checks, all that the services would need to do is just reroute to the appropriate backend and core service, whether it is a Quarkus application developed from, let's say, our team, or be it a Jakarta application or any other layer and resource, like, for example, an application servicing any kind of resource, like a database, for example. So we decided to use Vertex, and based on
This is what I was going to ask about the Vertex web proxy thing. Yeah. I was
yeah,
going to
yeah.
ask if you were using that.
So based on at that time current experience, we decided to go with the Vertex Core choice and not make use of the Quarkus Vertex extension, which gives actually access to the Vertex instance itself when you inject it in one of your, let's say, managed bins. And we did that in order to make use the routes of the web client. So whatever we would do as standard checks, we named after the handler interface. So the Vertex handler interface offers a way to handle actually something like intercepting the request, incoming request, in order to do some things. So we made the proxy handler. I can also give you some snippets later on. So the proxy handler is actually just a basic abstract implementation, giving some init and ending methods for the handler interface of Vertex. And then our custom handlers kicked in, extending this proxy handler abstract object, which actually would do whatever we would like to perform on the request itself, including the rerouting, which is the most, let's say, characteristic thing of what these units. Other handling, let's say, processing logic is, for example, the JWT checking, also request logging and response logging, the rerouting, which is actually what you would do when you actually find what the request API is, and also a standard check, which is next to JWT, but it's something more business, let's say, oriented and more SG oriented. So what we do have some configuration. The configuration actually kicks in once in the application lifetime. So when you init your application, you do have a method observing the router, and the router object is actually an instance of the Vertex web router. So whenever a router object is available, then we configure the routes for this router. And by routes, we refer to application properties, actually, meaning that we do have some source APIs that needs to be mapped to some destination APIs. And this mapping property here is actually just a small array application config into our application. So what this snippet here does is that for each proxy and mappings, proxy is the object that contains the application properties that we need. So for each of these properties, just create a handler and bring back an instance of a handler itself. And what an actual handler look like is that, of course, you get the routing context in order to do some operations in it. And based on making use of the web client itself, Vertex web client, you would prepare a request, a web client request that would be, let's say, performed at the end of this rerouting handler. So after all the checks made and after all the checks have been passed or the validations, then you would be able to reroute the request to the actual target. Would you like to give you an overview of how, let's say, an actual unit would look like after it got this dependency? So if you
Yeah, sure. Yeah, let's see.
let me share my screen then, and by screen I mean, sorry, let me share my whole screen. Okay, suppose you can see my screen again. Opening my development box. So this is actually the so-called RCS Commons proxy. It is the library that we were making, let's say, we were referring before. This
Maybe
is the
make it
package.
bigger also, just to
Yeah, a little bigger. Make the screen a little bigger, or the font a little bigger. That would be great.
Okay. And for this, I need now to actually.
Just write font and.
Font in the appearance, I think.
No, you need to go to editor font.
Yes.
It's right a little bit below. A little bit. There you go. A little below, two things below. Yeah, there it is. And you can change it the size.
There is an option for actually.
Yeah, that if you can get
with
that to work.
with a mouse. Give me a moment to.
But you
Yeah, here it is. Here it is. Sorry.
Okay. Yeah, if that works.
Actually, it's funny because every time we do the lessons that Panos mentioned before, every time this option is always unticked, and we do have taken. Anyway, so what this actually code base features. So we do have. Actually, let me go reverse. So this is how an actual unit. This is just a unit that it is a deployable unit into as a Docker image into the OpenShift container. Okay, no code. The only thing that you need to do, and in order to, let's say, to facilitate this dummy, let's say, pass-through with some standard checks. So what you need to do is just define, this is the proxy configuration that I was referring to before. So we were making use of the standard.
Just make it a little bigger because I think people on YouTube will have a hard time reading it.
Okay. Here it is.
Yeah, that's great. Yeah, thanks.
So here we're just making use of Quarkus, let's say, application configuration capabilities through the small array config extension. Another one that we didn't mention. So this means that whenever I get a source request in this, just forward this to this, and here you see that it has an addition. The addition is actually the backend service, the core backend service that actually performs all the business logic itself. There are also some other, let's say, configuration options, for example, and no other code whatsoever, because if we go to the dependencies itself, we see that it has this specific library that contains all the rerouting logic itself. So if I go to our RCS Commons proxy, RCS actually is the gateway platform that we're developing as team, the retail channel system. So if we go back to the library that is being shared among the various integration gateway services, the various pass-through services, we can see that we do have a configuration bin, which is actually getting the Vertex instance injected, as well as the proxy itself. The proxy is actually an interface that has all the configuration, and listening to the router, the Vertex router object, we do some initial configuration. These things only runs once, the application initialization. It provides basic routes to the router itself. So giving configured routes to the router, it gives the ability to Vertex to identify that you need to run specific handler for this specific endpoint. And here, when a request actually comes for this endpoint that it is mapped for this route, then you would execute the logic being contained in one of these handlers. For example, this is an example about the rerouting one.
Right.
This is the order. So we first make, let's say, the request handling, the request logging. If the mapping is about to be subject to authentication, we do the JWT handling, of course, and additional authentication checks, authorization authentication. And then we reroute to the target destination if everything goes well with the checks themselves. And what it does is that it recreates, for example, the head and the query, actually the whole request, for being redirected to the destination host, which comes due to the mapping contained again, injected into the object itself and into the routing context. This is, let's say, the use case that we thought that Vertex is actually would be a very, very good map, and it paid off, because right now we're in the position to spawn gateway units with no or very, very less code, like in this case, being dependent on only configuration properties.
I would agree. This is a perfect use case for Vertex.
Yes, and that's why we thought it would be a good use. And let's say, in order to demonstrate that a bit, what we have to do is just, here you see that I already have an instance running. If I didn't, we're just spawning this with Quarkus dev command, which is being offered, of course, from the relevant Maven plugin, where we're using Maven as build, although we did know, let's say, that we could have gone with Quarkus itself. So if I also go to the dependencies that I have here, you would see that we do have some in-house libraries like the ones, which do have the configuration that we need. And right here, the rerouting handler also lays. So if I add a debug point, and also start the debugger as well. By the way, this is a decompiled one. This is not the same the exact same code that exists in the library. If I go back and try to request that request here, the one that refers to the gateway service, indeed, I would say that the application did not stop in the configuration, and it went directly to the handler that actually would construct the whole, let's say, destination mapping and give back. You would see here the logging as well, that it performs the various validations, checks, the redirections with a rerouting proxy handler, and also logging some performance records as well, in order to give back a response to the outer initiator, which is the terminal or the front end itself. And this is the response also that I got. Okay. I think if you do not have any other questions, on this.
We have another
But
5 minutes, maybe, so we should start wrapping up.
regarding the experience, it was very, very seamless. Of course, we are looking into a way to use the Quarkus Vertex itself and see what it offers in terms of efficiency, of course, and development model. I'm not sure whether we can progress, of course. Pano, if you would like to.
Yeah, well, for the future, we have a lot of stuff. We want to extend the uses of reactive programming. We want to use more Quarkus extensions. As I said before, we're examining the option of Quarkus native. Although we didn't want to go so, let's say, we didn't want to be so radical at the beginning and go with a native. I see now there are inside the company, especially the upper management, some people that like the native.
Actually, they got really excited about what the native offers to and brings to the table.
Correct.
Next
So
slide, by the
currently,
way. I think it's your next slide you are talking about. Yeah. Okay, go ahead.
yeah. So yeah, we are examining that option. We will see. I mean, one of the reasons that we didn't go with a native right from the start and we went through JVM, I guess it was, let's say, the development style or the special handling, let's say, that the native might entail. So, given our background, a lot of people came from the Spring world, other people came from the Jakarta enterprise, as I said. Going native was, let's say, something like a big jump. We were happy in the first place that Quarkus was, let's say, approved and adopted by the company. Now, a few months later, we're already talking about native. This is very exciting for us, and we will see how it goes. Maybe in a few months we can have another session to talk about it as well. And also in the DevOps side, we are going definitely to run some performance and load testing. I would say that another team that is very happy of using Quarkus is the DevOps team. They like, the fact that the deployments are faster. I mean, the size of the artifacts the sizes of the artifacts are smaller. They do not, have to do a lot of stuff in terms of Dockerizing or configuring stuff from like environmental variables, etc. All this stuff are handled very seamlessly with Quarkus. And for us, it's very good that we have also the DevOps team. They are in favor of using Quarkus as well. So this is another good sign.
Yeah,
for Quarkus.
I've always found that always helps when you're advocating for something new.
Yeah. Now, also, as I mentioned before, we have some asks. Basically, that has to do with this is the next slide. Chris, yeah, this what we would like to have is some let's say help with using annotations and having an external caching server like Redis and Hazelcast. I think we know of, there are paradigms like in the Spring data where there are some cacheable annotations there, where you can configure with an external server, and you can have cast operations are almost very easily. We haven't. I don't know if it's in the roadmap or if someone else has asked as well. So that's one of our asks.
George, do you remember how much of this we support? We definitely have support for InfiniSpan, which is like a similar caching.
Yeah, we do, but the thing is, we don't have it like automatically tied with the caching annotations, right? So currently it's like two different things. We definitely could look into like using like a different caching backend for no for the caching infrastructure. So yeah, like the guy said earlier, what we're doing now is we're just using like in-memory caching. There's no external caching server being utilized. We could definitely do that. I mean, the person that actually did the caching stuff, he was an external contributor, but now he is part of Red Hat. So yeah, we should see
Nice.
with him and for the Infinispan team, yeah, what we can do there. I mean, it shouldn't be hard. It's just like, yeah, we need to prioritize it.
Yeah, I think what we have seen already from the annotations that are already in place. I mean, for using the annotation as a developer might not impose many changes there on that side, but there should be a configuration at some point where you configure the caching, let's say, the caching provider, whether it's in memory or an external one. So
Yeah, well, there could have been a problem, but there isn't because like we've have implemented it with like non-blocking in mind. So yeah, it shouldn't be a problem at the end of the day.
yeah. So if I try to think, as a Quarkus developer here, I think that you might not break a lot of stuff by introducing, an external caching server here. I think the default option could be obviously, an in-memory caching, and have the developer, configure if they want to have an external caching server here.
Yeah, I agree.
One question I have. So for the folks that use Quarkus, like how fast was the, let's say, adapting to Quarkus? Like, is it a matter of weeks, months, or what was your experience there?
Well, it depends what you mean, being, if you want, to start a new Quarkus application, you just go to Quarkus Starter, you create a project, put the extensions there, and it just works. So it might take only several minutes to have some working
being productive,
application.
like let's say you used something else before and you switch to that.
The feedback that we got, because we asked, let's say, developers from the Spring world, and also developers from the Jakarta world. From the Spring world, I would say something in terms of in the period of weeks, something like that. I mean, the programming paradigm is the same. All this stuff, the configuration stuff, let's say, that there is somehow there, and you just have to find how, so where to look and how to search. So it's not that hard. So that's why I said I think several weeks would suffice, to say that you are productive with Quarkus. And if you come from the Jakarta,
was the docs, the documentation around Quarkus was sufficient for you?
I think, yeah, Chris, I don't know if you have any other.
So I will come into the documentation thing. For me personally, it was almost a very fluent, let's say, transition, meaning that the concepts were the same. Meaning that, okay, you would need to have, let's say, some managed beans, of course, that need to be injected in other beans. So for those who were coming either from the Jakarta CDI or from the Spring injection mechanism, you would get, let's say, the understanding at a bit. And then you would get also all these sensible defaults coming through the application property of course, in combination with the documentation that exists, which is very intuitive at some very, very, let's say, representative scenarios. So, for example, how am I supposed to develop an API with REST easy, for example? So you would need these dependencies, you would need these annotations. Here you are. Just run the MVN Quarkus dev and you have a running Quarkus application. Of course, the details should be, let's say, evident the deeper you dive into the application development itself. But in combination with the magic that you encounter, so for Java developers, the magic was that you would hit a button and you would have a hot reload of the application as you were refreshing a browser or something. So these were, let's say, something that actually attracted you in order to get deeper into the Quarkus experience itself. And in combination also with the optimization and also what you save in terms of first request, the footprint, the runtime optimizations provided at the build time. So the execution engine would have everything in place so as not to decide the paths at this specific execution point. So all this in combination actually make a very good experience that is indulging for the next steps to come. I think that I couldn't be more, let's say, flattering for this.
I
We
would say that
appreciate
As an advice, as an
being
advice,
productive,
as an
yeah.
advice for the Quarkus development team itself, it would be keep it light. Keep
That's
it light.
developer joy. That's what it is.
Yeah.
Yeah,
Describe it.
yeah. If you want, to do some basic stuff like JAX-RS, Hibernate stuff with Panas, etc., I guess it's very, I would say that it's very easy. I mean, to be productive, you might need just 1 or 2 weeks. It's nothing very special. If you want to go a bit further and you have maybe more special cases, like maybe Vertex, it may be considered as a special case here. You need some more time, but it depends on the experience of the developer. If someone's very experienced with Spring, then he can go to the Quarkus very, very easily without, having to change anything in the how, to build and run stuff in a containerized or in a framework like Quarkus, which is, of course, has an embedded application server, has all this dependency injection magic, etc. So
Got it.
nothing.
Well, folks, we have to wrap it up. We're over time.
Yeah.
I think it was great having you here, and we'll probably have you again after you deploy in production, and you can share some numbers with us.
Excellent. Yeah, definitely. We
Some
definitely
data
want that.
point.
Definitely, I think we have a lot of things to do in the future and a lot of things to anticipate for. So definitely, yeah. Thanks for having the opportunity to talk here, and maybe we can talk again in the future with more insights and more feedback as we move along with the framework.
Cool.
Thanks for the invitation and thanks for the support as well. We're grateful for this.
Thank you
Thank
both,
you.
guys.
Thank you.
Have a good day.
Have a good
Bye.
day.
Bye, everybody.